Yes, so now we're moving on to question number 4, which says work out the gradient of the line joining these pairs of points. So it's always about 2 points. The midpoint, the length, and now we're talking about the gradient. The midpoint is the middle point, the point in the middle. The length is the difference between, you know, how long the line segment is. Now the gradient now is the steepness of the slope. Okay, there isn't any real mathematical established conventional symbol for midpoint, so you can use MID, PT. You can just use L leisurely for length, but there's an established letter for gradient, which is M. Why M? Some people say because M now is for monter in French, to climb, to mount, because G could not be used because G was already used for gravity. Although gradient starts with G, but they use M. And M now, most of the mathematicians use M because they say most likely M now is in French for the first letter is to climb, in French is monter, to mount, because gradient represents the steepness of the slope, up the slope, down the slope. Okay, so therefore now the formula now has an M in it. M is equal to, so just bear in mind, the international symbol for gradient is M. Okay, so here we have it, gradient. Okay, and we use the letter M, which of course you all should be familiar with that already. M now is a ratio. The gradient is a ratio. Is in terms of, in words, is rise over run. Now probably the words rise over run does not say much. All right, so you can say is like the rate at which, all right, you are climbing with regards to going horizontal. All right, the rate at which the vertical is increasing or decreasing with respect to the horizontal. All right, when you say rise, another word for saying rise, you can say vertical change, vertical change divided by horizontal change. So as I was saying, the rate is a rate at which the vertical changing with respect to the horizontal, the rate at which the vertical changing with respect to the horizontal. All right, you can use that for gradient here. We can see in brackets the rate, I'll put that in simple, the rate at which the vertical varies or changes, all right, with respect to, all right, to the variation to the horizontal variation. Now I need to add here that as you climb up the academic ladder, you're going to come across gradient, and there's a special topic in mathematics called calculus, and you'll be coming across that again in your university studies, okay, called differentiation. All right, so differentiation has its roots in gradient. All right, you're differentiating between how much your vertical is changing with respect to your horizontal. Now these are words, so we need to put that in symbols. Now your vertical change, now we always have to associate the vertical with the y-axis. So we're looking at a vertical change is y2 minus y1. Okay, y2 minus y1 divided by x2 minus x1. Okay. Vertical change divided by horizontal change. So in a nutshell, gradient is a ratio, it's a rate of change of vertical with respect to horizontal. All right, so bear that in mind. So in a nutshell, you can say calculate, as an example, calculate gradient of the line. All right, calculate the gradient of the line. Segment, if you will, that joins the points. So you must have 2 points. Okay, you must have 2 points. Let's call it A again, and you can put negative 13, comma. All right, and you can say negative 7. Now, as we are there now, we know that we have to label the coordinates. So let's just do that one time. Okay, so let's call that x1, just to speed things up. And let's call that y1, that's the first point. So its coordinates will be the ones, if you want to put it that way. All right, x1 and y1. All right, so let's just copy this. All right, so you have A, the points A and B. Okay, so B now will be, for example, let us say negative 9, for example, and let's see, say 15. So B will be the second point, so its coordinates will be the 2's, x2 and y2. So we have them labeled already. So all we need to do is substitute into the formula. All right, solution, substitute into the formula. Okay, so we're doing all of this, right? Substitute into the formula one time. So we have the coordinates labeled. Okay, we know that x1 is negative 13. Y1 is negative 7. So, and y2 now is 15. So where we have y2, we put 15. And where we have y1, we put negative 7, as you can see. Negative 7. The formula comes with a negative sign. All right. So here we have 2 negatives, one for the formula and one for the 7. x2 now is negative 9. And y and x1 is negative 14. The formula comes with 14. But we need another negative sign, one for the formula and one for the 14. So you have to be very careful when you see you are doing the calculations to find your height. Very important. So we have 15 minus 7, 15 plus 7, negative 9, subtract negative 14, negative 9 plus 13, 15 plus 13, 15 plus 7, that will give us 22, negative 9, so plus 14, you take it out 9 from 14, you will take out 9 from 14, you are left with 4. Right, you can prove it in your calculator, negative 9 plus 14, okay, and 15 plus 7. Always good to cross check. This can be simplified. All right, this can be simplified to 22 divided and 11, sorry, 11 divided by 2. Okay, So the gradient is basically 11 divided by 2 in that case. So you can leave your answer as a fraction if you want. You can put it as a decimal. You have a nice permanent decimal here, 5.5. Okay. It's always good to interpret. All right. The midpoint is the middle point. All right. The length is how long is the line, but the gradient now is a rate of change. So it's always good to interpret what that 5.5 means. What does that 5.5 mean? It is a rate of change. What does that mean? Okay, so let's take a little time to interpret this value. This means that, all right, there are different ways of phrasing it, but I'm trying to be colloquial as possible. This means that each time all right, the x values increase by 1, always 1, O-N-E, the symbol 1, always 1 when you see interpreting the gradient with regards to the x values. So each time the x values increase by 1, the y values increase by 5.5 by the gradient value. All right, so in other words, every unit, because unit means 1, with every unit change of every unit variation of the x values, there is a corresponding 5.5 variation y values. So each time the x values changes by 1, the y value is changing by 5.5. Okay, so it's very important to interpret these values. Midpoint is the point in the middle. Length is how long is the line, but gradient now is a rate of change of the y values with respect to the x values. Okay, very important concept, the gradient. Right, so as we say, pencil and paper, you practice that, and then you apply it now to those questions in number 4, gradient. Always have your pencil and paper at hand to write, because mathematics is a skill, something that you have to actually do. It's like a physical activity, which of course is writing and interpretation of numbers.